morning. Good morning, everyone.
Hi.
Can everyone hear on Zoom? Nick, can you say something?
Hello.
Very good, very good. So we're starting with the software session. Actually, Eric is leading, but I'm just introducing Nick because he's been working with me all these years. Nick started as a student with me at the Google Summer of Code, and he's been faithfully working and continuing with working on the tool set. So we have something very exciting to present to you. And Nick, unfortunately, he wanted to come. We had his flight booked and his Airbnb and everything, but Israel had a problem and he couldn't leave. Yeah, so there were no flights of Israel until the 12th. So we hope to get Nick later to Memphis. So Nick, pray start.
Okay. Thanks for the introduction. I'm starting. So today I'd like to present a new columnar file format, which is intended for storing alignment data in a more efficient way. Essentially, we want to replace GBAM for certain applications, fitting applications. I'm showing my next slide now. So basically, GBAM is a BAM file, but each alignment record in it is split between different columns so that it becomes possible to skip certain fields in the data if you don't need them. Like in the image, you could see, you can imagine that the second part of the image where it says row oriented layout, it's essentially a BAM file. So each row is compressed separately. And if the red cells contain 400 gigabytes of data and the green ones only 10 megabytes of data, you couldn't quite get this 10 megabytes of data without decompressing 400 gigabytes with it. And in the case of GBAM, the bottommost part of the picture, you could easily skip the red things. So only read what you need, only pay for that. So there are already a few open source columnar file formats available, like Apache Parquet. A Parquet file structure is demonstrated on my slide now, but the problem with them is that they are quite complicated, and for a non-very tech-savvy person, it would be quite difficult to tinker with these formats. So we decided to come up with something new, something easy. And on this slide, you could see like a very rough representation of the file structure of GBAM and BAM. So as you can see, the GBAM is quite straightforward. Main chunk of work went into optimizing the software, but the logic, if we ignore the optimizations made, is pretty simple. In fact, I made a small parser in Python just to demonstrate the simplicity. It won't fit in the slide, but it's only 100 lines of code. And I think for Parquet, you probably would need at least 1,000 or more. So we also have a Rust API of the software, and it's trivial to use. You could utilize our writer or parser or some other tools easily just by requesting GBAM package from Rest Package Manager called Cargo. And our GBAM reader can be used in multi-threaded environments and is very well optimized. So we also offer a command line interface. We don't have much tools yet, but for those which are implemented, we try to mimic SemTools interface. So it wouldn't be too foreign for you if you'd like to use it. Also, due to presence of metadata in each GBAM file, it supports random access for sequence data out of the box without index, which could be imported for some interactive tools, like, for example, GFA Estus or GFA Estus by Chris Fisher. It's a graph viewer, and you could see a screenshot from this program on the slide. Also, GBAM is already utilized in a GFA inject tool by Andrea Gorecina. And about the metrics, we re-implemented a few SemTools routines based on GBAM. So these routines are read depth, flex statistics, and sorting, and all of them showed a significant speed up, mainly due to much reduced amount of the data processed. So some routines, such as depth, depending on the file origin, can utilize most of the data in the file. Then we don't get exactly a great speed up, but sometimes it's pretty good. But for routines such as flexstat and index sort, we've got great results, as you could see on the slide. So index sort is a bit of a novel thing we came up with. So it's a sort where we don't actually reorder the data, but only the indices of the data. And since some routines, bioinformatics routines, only depend on like can operate based on integers only. They don't need strings at runtime, so to say. So you could on the read stage just convert everything to integers, and even a very big file, data extracted from a very big file, can fit completely into RAM. So in these cases, it's possible to just reorder everything after the fact, after you converted everything to integers, and you don't really need the order of the data, which is very expensive to produce. Like a proper sort, as you could see, only gave a 10% speed up compared to some tool sort or some Bamba sort, and it's probably because we use different compression algorithm. So since the conversion from BAM to GBAM is not free, GBAM is mainly intended for workflows where sorting of the data is necessary. And we implemented sorting routines which take BAM file as an input and produce a sorted GBAM file. So you could use that. And we tested all of the routines we've made, also converters, parsers. We tested them on files of up to 1 terabyte in size and found no issues. And currently a paper is in preparation. So the most popular tool for working with BAM files is SemTools, and also there is SemBamba, which is a faster alternative to SemTools, made by Petr Prince, one of the author of GBAM. As you could see on the slide, we aim to improve only the smaller part of the alignment workflow. However, it still accounts for a sizable chunk of time spent in the workflow. So I think it's worthwhile. And in the future, we plan to use it for pangenome graphs. It could potentially be used to reference pangenome graph nodes on disk. And in general, BAM file would be difficult to use with random access stuff on very big files. So we need a new format. And also we may extend GBAM to store not only biology data, but something else, maybe even support a simple schema. So you could store any data you want. We plan to add support for GBAM to more tools, like we did to GFA inject, and port more of the SemTools functionality like marked-up, which I think can be a great candidate. But we didn't do it yet since optimized routine is somewhat complicated, difficult code. So GBAM is available on GitHub, the first link. And if you would need any help with the software or have some ideas, feel free to reach out to me or to Peter. So second link is my email. That's it.